Today's topic is electrical power and the relation between torque, power and speed. Today's information is about the inventor of steam engine, James Watt. James Watt is a mechanical engineer from Scotland, born on 19th January 1736, died on 25th August 1819. 83 years he lived in this planet. In his childhood days, he suffered from toothache. He was unable to attend the classes regularly. His mother taught reading. His father taught writing and arithmetics. During his teenage period, he lost his mother and father. His father owned a workshop. His hobby is to assemble the toolkits. So he decided to pursue a career in mathematical instrument making. In the year 1755, he learned the art of instruments making from John Robert. In the year 1757, with the help of his friends, he set up a workshop in the Glasgow University to repair university mathematical instruments. In the year 1758, he studied the technicalities of instruments with the help of Glasgow University professors. In the year 1763 is considered a crucial period or a turning point in his life. He studied the Nicroman steam engine, which is not working properly. He was asked to repair the steam engine. He studied the engine in 2 years, that is 1763 to 1765. In the year 1765, he devised a unique way to modify the engine to improve the working, which led to the invention of the steam engine. It is considered as one of the greatest achievements of all times. In the year 1960, the 11th General Conference on Weights and Measures incorporated watt as the unit of power in International System of Units. So what is a scientist name? The details are available in famouspeople.com. Please go through it. Now we'll see the derivation of electrical power and the relation between power, torque and speed. Electrical power. Here work is done whenever a force causes motion. And I push the camera or a laptop, a work is done. Power P is equal to rate at which this work is done is called electrical power. Its unit is in watts. Power P is equal to V into I. And DC side, in AC side, power P is equal to V into I into cos theta, where cos theta is a power factor. We know that voltage or an EMF, electromotive force, which is required, which will give a force to move the electrons. The product of V and I will give the power. We know that V is equal to energy by charge, that is E by Q, and I is equal to charge by time, that is Q by T. We simply multiply, we will get energy by time, that is joules per second. Therefore 1 watt is equal to 1 joule per second, and 1 watt second is equal to 1 joule. Power is also in terms of kilowatts or in megawatts. Kilowatt 10 power 3, megawatt 10 power 6. Now we will see the relation between power, torque and speed. P is equal to power developed by the rotor, T is torque exerted by the rotor, and omega is the angular speed in radians per second, and n is the speed of the rotor revolution per second. Therefore, n revolution are made in 1 second is equal to T is equal to 1 by n. Here F is equal to force and the distance R is equal to radius. Therefore, omega is equal to theta by T, that is angular distance in radians per second, theta by T. Therefore, omega is equal to 2 pi divided by 1 by n, that is equal to 2 pi into n. Work done in 1 revolution is equal to force into distance, that is force into distance r, that is 2 pi r in 1 revolution. Therefore T is equal to torque, force into distance is equal to F into r. So I can write F into r is equal to T. Therefore T into 2 pi is equal to 2 pi T is a torque, that is work done in 1 revolution is 2 pi T. Now this is the 2 pi N into T. Therefore power is equal to work done by second. Therefore 2 pi T divided by T, 1 by N, T is equal to 1 by N. Therefore power is equal to 2 pi N into T. These derivations are available in all textbooks. Please refer. Now we will work out some problems. The first problem, a load current of 200 amps is supplied by two cables connected in parallel. One cable is of copper and another is of aluminum. Each cable has a length of 200 meters and a cross-sectional area of 40 mm square. Find A. Current in each cable, B. Voltage drop in each cable, C. Current density in each cable, D. Power dissipated in each cable. Here the load current is given, that is 200 amps, and the cable are connected in parallel. In parallel circuit voltage is constant. The length of the cable is given 200 meters and cross-sectional area is given 40 mm square. Then we can easily find its resistance. R is equal to rho L by A. We know L, we know the resistivity. Resistivity is given for a copper 1.7 into 10 power minus 8 ohm meter. For aluminium 2.83 into 10 power minus 8 ohm meter. Therefore resistance, simply substitute in the formula R is equal to rho L by A. The resistance of the copper is 0.089 ohms. Similarly the resistance of the aluminium is 0.142 ohms. Therefore we can find, we know the current, applying the current divider equation. Therefore current divider, we can find the current in the copper cable because we know the two resistance and know the total current. The copper I into R2 divided by R1 plus R2. Let me say this is R1, this is R2. Therefore what is the current in the copper cable? We can find, that is the I into R2 divided by R1 plus R2. I is the 200. 200 into 0.142 divided by 0.089 plus 0.142, that is equal to 122.94 amps. Current through the copper cable is 122.94 amps. The total current is 200. Therefore remaining current will flow in the aluminum cable. Therefore 200 minus 122.94 is equal to 77.06. So this is 79.06. The voltage drop is equal to I into R. We know the current and we know the resistance. Therefore this is 10.94. And similarly we can find the voltage drop in the aluminum cable, that is 77.06 into 0.142 is equal to 10.94. Here the problem is correct. Voltage across the aluminum cable is equal to voltage across the copper cable. Now we have to find the current density. Current density is nothing but total current divided by cross-sectional area, that is ampere per mm square. This is mm square. Here 122.94 divided by 40 will get 3.074 amps per mm square. Similarly, I is equal to 77.06 divided by 40 is equal to 1.752 amps per mm square. This is the current density. This part is over. The third is, we have to find what is the power dissipation. That's the last part. I square R. We know the current, that is I 122.94 I square into R, we will get 1345.17. Similarly for aluminium, we can find I square R is equal to 77.06 the whole square into 0.142, we will get 843.23. Therefore the total power is equal to 2188. Here we know the voltage. Voltage is 10.94. The current is 200. This is a check. This is P is equal to 200 into 10.94. We will get 2188. Here the power dissipation is also 2188. The problem is correct. The second problem, two resistors R1 and R2 are connected in parallel as shown in figure. Find A. The current supplied by the battery. B. Battery voltage if power dissipated in resistance R1 is 48 watts. C. Find the power dissipation in the resistance R2. In the second problem, power dissipation in the resistance R1 is given, that is 48 watts. Therefore, I square into R1 is equal to 48. Therefore, I square is equal to 48 divided by 12. Therefore, I is equal to 2 amps. Current flow in the 12 ohm resistance is 2 amps. We can easily find. Because this value is given. I square into R1 is given. Naturally, we can find. Next is, we have to find what is the total current. That is the current supplied by the battery. By using the current divider equation, we can find I1 is equal to I into R2 divided by R1 plus R2. We know of the value of I1. I1 is equal to 2. And I into R2, I into 20 divided by R1 plus R2, that is equal to 32. But we can find the current supplied by the battery is equal to 3.2 amps. Therefore, the current flowing in the 20 ohm resistance is 1.2. That is 3.2 minus 2, that is equal to 1.2 amps. Now, what is the total resistance? Total resistance is equal to, this is in parallel, 20 into 12 divided by 20 plus 12. That is equal to 7.5 ohms. Total resistance is 7.5 ohms. Therefore, battery voltage is equal to the current, we know the total current, the current supplied by the battery. Therefore, battery voltage is equal to 3.2 into 7.5, 24 volts. Battery voltage is 24. Now, we can have to find what is the power dissipation in the 20 ohm resistor. We know that power dissipation in the 48 R1 resistance is 48. Therefore, R1 is, that is 2 square into 12 is equal to 48, which is given in the correct, problem is correct. Then we have to find what is the power dissipation in the 20 ohm resistor. That is 1.2 the whole square into 20 is equal to 28.8. The total power dissipation is 48 plus 28.8 is equal to 76.8. We know the voltage and we know the current. Therefore, power P is equal to V into I, 24 into 3.2, that is 76.8. Power dissipation is 76.8. Power supplied by the battery is 76.8. The problem is correct. The third problem is, a 220 volt DC motor drive a pump lifting 1.2 meter cube of water per minute to a height of 20 meters. If the efficiency of the motor and the pump is 60%, determine A. Electrical power input. B. The current taken from the supply. Assume 1 meter cube of water has a mass of 1000 kg. So in this problem, voltage is given 220 volts and pump lifting 1.2 meter cube of water per minute, that is given, that is 1.2 meter cube is given, and assume 1 meter cube of water is equal to 1000 kg. Therefore, mass of water is equal to 1.2 into 1000 is equal to 1200 kg. Next is the efficiency of the pump and water is given, that is 60%, that is 0.6. Then we can calculate the weight of the water is equal to m into g, mass into that is g. 1200 into 9.81 will get in newtons, 11,772 newtons. Now we can calculate work done per minute. Work done per minute is equal to force into distance. The force is m into g, that is 11,772 into 20. Height is given, that is 20. We will get this value, that is 2,35,440 Newton meter. Now we can calculate work done per second. Simply we know that work done per minute divided by 60, we will get 3,924 joules per second. 1 watt is equal to 1 joule per second. Therefore, 3,924 can be written as 3,924 watts or 3.924 kilowatts. The efficiency is equal to output by input. The output by input is given, that is 0.6, value is given. Therefore, input is equal to 3,924 divided by 0.6, that is 6540 watts. 6,540 watts or 6.540 kilowatts. The input power is 6,540 watts. Power P is equal to V into I. We know power 6540 divided by 220. We can calculate the current. Current is equal to 29.72 amps. Electric power input is 6540. The current taken from the supply is 29.72 amps. The fourth problem is, an electric motor has 150 conductors, each exerting a force of 10 newtons at a radius of 80 mm. Determine the power developed by the motor at a speed of 750 revolution per minute. In this problem, number of conductors is given, that is 150. Each conductor exerting a force is 10 newtons. At a radius given, that is 80 mm. So power developed at a speed of 750 revolution per minute we have to find. What is the power? We know the force as well as the radius, that is given. We can easily calculate the torque. Torque is equal to force into distance. Here R value is given. Therefore T is equal to 10 into 80 into 10 power minus 3. We will get 0.8 Newton meter. That is, torque exerted by one conductor is 0.8 Newton meter. And the total number of conductors is 150. Therefore 150 into 0.8 we will get 120 Newton meter. The formula is 2 pi n into T, where n is the speed, that is in revolution per second, but in the problem is given 750 revolution per minute. We can convert 750 divided by 60, we will get revolution per second. 750 divided by 60 is equal to 12.5 revolution per second. So we know all the values. Simply substitute in the formula. 2 pi into 12.5 into 120. We'll get 9420 watts. R power P is equal to 9.420 kilowatts. So this is the formula. Already we have derived 2 pi n into T. So what is the power developed at a speed of 750 revolution per minute is 9.420 kilowatts. The fifth problem is 6 resistors are connected as shown in figure. All are in ohms. Find the power dissipation in the 10 ohm resistor and 60 ohm resistor. This is a question. Here 6 resistors 10, 20, 30, 40, 50, 60 are connected as shown in figure. The supply voltage is 100 volts. Here the point A, B, C, I marked it. Here the A and C is connected, D and B is connected. Therefore I mark A, C and D and B. This is the point. Here the two resistors, one is 10 ohms and another is 50 ohms. So I mark 10 as well as 50. Now A and D, one resistance A and D is 60 ohms is connected. A and D is connected 60. A and B is 20 ohms. And B and C is 30 ohms. D and C is 40 ohms. Here 60, 20, 30, 40 all are connected in parallel. Therefore I have to find the total resistance. 1 by R is equal to 1 by 60 plus 1 by 20 plus 1 by 30 plus 1 by 40, that is equal to 8 ohms. The resistance is 8 ohms. The 10 ohm and 15 ohm resistance are connected in series with the 8 ohms. Therefore total resistance is 68 ohms. Therefore I is equal to V by R. 100 divided by 68 we will get 1.47 amps. This is 1.47 amps. So we have to find what is the power dissipation in the 10 ohm resistor. Therefore current flow in the 10 ohm resistance is 1.4. Similarly current flow in the 50 ohm resistance is 1.47. Therefore power dissipation in the 10 ohm resistance is I square into R. 1.47 whole square into 10 is equal to 21.60. Part 1 is over. Next I have to find what is the voltage across the 10 ohm 60 ohm resistor. Then only I can find the current. Here the two resistors, one is 10, another is 50. Therefore the 10 ohm resistance voltage is 14.7. Similarly voltage drop in the 50 ohm resistance is 73.5. That is V, that is 1.47 into 50. The total drop is 88.2. 100 minus 88.2, we will get 11.8 volts. Voltage across 60 is 11.8, 20 is 11.8, 30 is 11.8, 40 is 11.8 because all are connected in parallel. Once I know the voltage and resistance, I can find the current 0.197. Current flow in the 20 ohm resistance is 0.59. Current flow in the 30 ohm resistance is 0.393. Current flow in the 40 ohm resistance is 0.3. So I sum all the values, that is equal to 1.47. Okay, here the problem is correct. Current towards the junction is current leaving the junction, that is 1.47. Now I have to find what is the power dissipation in the 60 ohm resistor, that is 0.197 the whole square into 60, 2.33 watts. So the power dissipation in the 10 ohm resistor is 21.60. Power dissipation in the 60 ohm resistance is 2.33 watts. With this I conclude my lecture. Thanks for listening.